Sometimes I find it very hard to insist deliver the videos. Okay. Boys and girls, where to my videos? And in this video, I will introduce a new function of Unity. It's about the shader graph. I think probably you have know what a shader is. But in this video, I will introduce what is a shader and briefly. So let's have a look at the scenery of our scenery. This is the scenery from Unity Asset Store. We can see that there are some interesting pictures here. You can see that. This is the textures, and here is the model. Okay? And this is the house. We could scroll around the house, and we could click one object and use the F keys to navigate to this object. We can see that there are many different kinds of objects. Here is the logo of Unity, right? So this scenery is very interesting. And we can see that in this desk, there are four items. These are created by me and to test the material of the Unity. And many interesting items in this room. In this lecture video, I won't do any programming, but just give a brief introduction of the material system of the Unity. And we can see that let's choose one item, for example, this apple. And we can see that in the left hierarchical window, the apple is highlighted. And this apple has, we can see that there is only a transform component attached to this apple. But it has two sub-child objects, the apple body and the apple stem. Okay, so these are the real body of the apple. And if we choose the apple body, in the inspector window, we could see that there are some components. And since we have introduced the transform, in this video, I will introduce the mesh components. We can see that there are two components which has a mesh in the name. The first is the mesh filter. The second is mesh render. The mesh filter is a component which has only one member. This member is the mesh. So in the coding layer, I think it's implemented by a pointer which points to a mesh. And the mesh is something like some verticals and edges. So I will show you what the mesh looks like. Let's go back to the scenery. And here we can see that there is a toggle button. Okay, and we could have a try that. You can see that the latch, there is a latch. Okay, the grid is open, and if you click again, the grid disappeared. So we could choose to X. You can see that the direction of the grid is changed. So in the default setting, it is the grid plane is set to Y plane and it is open, but we can close it. And here is another function, but I haven't tried it. And to the right side, we can see that there are some draw mode. Okay, this is very useful. And if we choose the shaded wireframe mode, you can see all the color disappeared, right? There are only the lines lived here. And in this case, we could have observation of what the mesh looks like, you can see that there are many triangles, right? The lines of the triangles, and these are the meshes. And in data structure, it is represented by the vertices. Many of the vertices and maybe the index, and it's basically this set of triangles. So this is what the mesh looks like. And we could switch back to the normal shading mode. Okay. So this is the mesh, and we can see that here is a mesh called apple body. In fact, we could choose other kind of mesh. You can see that the object suddenly changed, right? If I switch the mesh, the object changed to another object. So this is a mesh. It defines the shape of the object. Let's go back to the apple body. Okay. And here is another component called the mesh renderer. This component is used for render the mesh. It depends on what's the mesh, like the color of the mesh, or the visual effect of the mesh. And we can see that there is an element called in the materials title. And we can see that there is an element 0, the apple true. So I think in Unity, one mesh could composed by several submesh. And I think each of the submesh corresponded to an element of the materials. So probably this mesh have only one submesh, and this is the material corresponding to the mesh. And the material determine that how the mesh is rendered. And we can see that we have attached material here. And the material is apple red true, okay? So we want to have a look at what the material looks like. And we could we can see that the material is in the project window. So if I click it, we can see the details of the material. And there are some important parameters of the material. First, in this surface option, we can see there is a workflow mode. There are two modes, specular and metallic. Generally, this mode is to decide how to reflect the light. Okay, the other object could reflect the light, and specular is more physical character. A more physical correct way to describe how the object reflects light. And metallic is not very physical correct, but it's easy to use. So these are two modes. And if we change the mode, we can see that the parameter changes accordingly. It will also change. Okay. And so let's have a look at the metallic mode, and we can see that there is a base map. So the base map corresponds to the diffusion reflection in physics. And an easy way to understand it defines the color of the object. And there is a metallic map. This parameter determines that how much the object looks like a metal. Okay? If you make this parameter as high as possible, its value is between 0 and 1. And if you make it near 1, this object will looks like a metal. You can see that it's like metal, right? And it keep it to 0. And there is another parameter called smoothness. I won't go to details of these parameters, but Most of them are covered in the graphics, in the tutorial of graphics, computer graphics. There are many books and tutorials introducing about these parameters. If you are interested, you could go and have a look. And if you have write some shaders or you have tried to make some game engines, if you have used, you should have known some of them. Some of them at least. And let's go to have a look at the shader graph. Okay. I hope I can find the shader graph. Maybe I forgot how to open it. It seems like I forget how to open the shader graph. Or you can see that this is our materials. Okay, this material is created by me. So you can see that it is rotate, right? It rotates. And it is sometimes it is stopped, but it is sometimes rotate, but I'm not know why it sometimes stops. So this is the material, and this is the material which I created. And if you want to create a material, it's very simple. First, go to the file folder which you want to put your material in, and right click and create a material, and give it a name. For example, this is for testing, called testing. Okay. Then you click it, you will see that this is the material. And if there is a button called edit, left click it. Oh, if you left click it, it will open our VS Code. You can see that this is the source code of the shader. There is a shader bounding to a material. So I hope you have understand what is a shader. It's a piece of code which is run on GPU. So this is a shader, but I think it's this language created by Unity. And Unity will use some compiler or interpreter to translate this language to maybe to some standard shader language. And we can see that there are some codes, like this code looks like it looks a little like C language, right? Because this we can see that includes and the program this keyword of C language or C++ language. So it's a little bit like C language. But we won't go into the details because this video is not for how to write shaders. Okay. So let's close it. In fact, we want to have a look at the shader graph. But it seems like I forget how to. Okay, you can see that here is the shader graph. But in fact, I forgot how to open the shader graph. I just forget how to open it. You can see that this shader, if I close this tab, okay? Close this tab and click edit. It will open the shader graph. You can see that for that shader, I click edit, it opens the VS Code. But for this, it opens the shader graph, so it's probably because of the type are different, but I forget how to open it, so we will just use it, okay? And in this window, I will have an introduction of this window, okay? Because my screen is very small, so I will make it a little bigger. You can see that there are some elements in this window. First, you can see that there was a toolbar in the top. There is a toolbar. Okay, and this is the editor region, and we can see that there are some nodes in here. So this each one of this is each atom is a node, and here is here this blackboard. This item is called blackboard. So you could define some variables here. For example, you could it seems a little strange because or you can sometimes need to adjust it. You can see that here is a button. If you click it, you can choose a type. There are some default types, and for example, you can choose a float and give it a name. Okay, you could drag this item to the item here. Okay, but we want to use it. We just show you how to create a variable. We will delete it. So this is the variable I have created. There are some types like float, vect2, color. And if we create a new shader graph, okay, I just forget how to create a shader graph. Maybe just right click, create. Okay, here is the shader graph. You could create shader graph like this. There are many types of shader graph, and in this video I just introduced one, the lit shader graph. So in fact, I haven't tried other kind of shader graphs, but I think they are similar. And this URP is a kind of random pipeline. We know that. Let's switch to the Unity Hub. And if we create a new project, you could see that there are some templates here, right? The 3D and 2D. This is a 3D template which its name is building render pipeline. So there are different render pipeline used by Unity. The building render pipeline is the default one, and there are some other kind of templates which use other pipeline. We can see that there are a universal 3D pipeline, high definition 3D pipeline. And this universal 3D pipeline is what we use now. It's called the URP, the Universal Render Pipeline. So what's the difference between them? There are a lot of details here, but I just give a brief introduction. I think the built-in render pipeline is not the rendering performance is good, but the visual effect is not very good, especially compared to the universal render line. And this high definition 3D render pipeline has the highest quality, but it also needs the highest performance. It needs the it will consume the most of the calculation resource, such as the GPU and the CPU or something. So the universal 3D pipeline is it is optimized. Its performance is optimized, and it could run on web, on mobile, and on laptop. And it also has a good visual effect. So basically, it's just between the built-in render pipeline and the high definition pipeline, something between them, I think. So it's a good choice. A good choice to make a very general game, which has a good visual effect, and which is also which also could run on some small devices such as mobile. So our project is use the universal random pipeline. Let's close this since we don't want to create it. Okay, let's go to the shader graph. And I will create a new shader graph for you. And give each a name like my shader graph. Okay, my test shader graph. You can see that if I double click the shader graph, you can see there is nothing in the background, and you can see there are two nodes in the wheel. Okay. The vertex and the fragments. If you have used the shader language, you should know that this corresponds to the vertex shader, and this one corresponds to the fragment shader. Okay. And we can see that there are some parameters predefined, like the position, normal, and tangent. And in the fragment shader, there are base colors, the normal, and the metallic smoothness, emission, and ambient occlusion. So what we can do is we could first create some variable here, and this variable would be editable, where the artist use your material. And here is another window, the graph inspector. If you choose a node, this window will show the components of that node. Okay. And I remember there is another window, but it just disappeared. I can't see it. Oh, it's here. You could adjust the position of these windows. This is for preview what's the render effect of the shader. And you could just right click to create nodes, or you can also left click the blank position and click the spacebar. Then you could choose the type of node. Okay. So since there are many types of node, I can't remember the name. So I won't create anyone. Let's go to this graph which I have created for you. You can see there are many kinds of nodes. I will just pick some of them to introduce. So you can see there is a time, right? And I could type in time, and by this we could create time nodes. The time node it looks like this. So this means this is the time, and you could create a node called multiply. Basically, a multiply just has two inputs and one output. So its function is just multiply these two inputs and put the output here. And here the scroll speed is one variable I set in the blackboard. And if you click it, and you can see that it has parameters. This is 1, okay, I could make it to 0. But I will make it to 1, okay. It has name and some basic properties. And this is a divide, so this means that you A divides B. And we can see that there is another node called panning and offset. So what's the meaning of this node? Gradient noise. It basically is just a texture. Okay, I think it's a texture, and the texture looks like a noise. Then you could make some special effects, such as the texture has two parameters, the UV and the scale. So in this shader graph, we use a time to drive the flow. So this means that this true value will change according to the time. So this is why the texture looks like moving, keep changing. This is what we want. And then we made true, okay, true gradient noise, and then we multiply them together to make a special effect. Since there are many nodes, so sometimes it's hard to manage those. You could use a group to put the nodes together, like what we did. It's easy to create a group. Just choose the item and right click and because this item is included in a group, so I will create a new node. Okay. For example, I create the time. I think I could copy one. Okay. Use Control D to copy, and I choose this true one, and right click, and you can see there is a group selection. You can see that if you click, you could create a group. Okay, so this is a group. By group, you could move it. So it's just a way to manage the node to make it doesn't look messy. I will delete it since we won't use it. So basically, this is the shader graph. I think the Unity will transform the graph to a shader language and use in the rendering process. Okay. I won't tell just more about the details, but just give you some brief introduction. Get a feeling of how to use it. So this is it. Now, if you want to save, because I changed something, so I want to, you could click Save Assets to save your changes. But since I don't want to modify anything, so I just close it. And I will discard all the modification I made. And this also close it and discard. Okay. So this is, you could make some special effects looks like this. Look like this. Look like this effect because it's switch according to the time. It looks interesting, right? So you could implement some weird effects like a storm. But I think it will take some calculation resources, but it depends on your machine. Okay? So this is also a material created by me, and you can see that there are some parameters. Okay, you can see the parameter. You could adjust this parameter. And for this is I change it to 1. You can see that it suddenly changed. Okay? So you could adjust this parameter to get the real effect you want. Okay, I think it's enough for this video. Yeah, some you can see that this effect really interesting. It's awesome, right? This is awesome. I haven't changed haven't look how to implement that. But this definitely this special effect could be used in our games, right? And the implementation is very simple. It's not very hardcore. It's just maybe some operation on the material. We could use shader graph to implement functions like this. Okay. And this is the models, and we could see that we could have a see of the elements of the model. We can see that there is a body, right, and the skeleton. If we search the body, we can see that this is another kind of mesh render. It's called skinned mesh render. And you can see that it has a mesh. And it has many materials. So this means that one mesh can correspond to multiple materials. It's probably because that this mesh has many sub-meshes, so each sub-mesh corresponds to one material. And if we click the material, it will also be showing the project window, and we can have a look at what the material looks like. Okay. Maybe this there the shader here. The shader could be made by code or could be made by shader graph. I think this one is made by code, because if I click editing, open the Visual Studio, and here are also the parameters, which is very common in the shader in the materials. And this parameter comes from the code or the shader graph, according to your choice. Since you can see that this is go back to this one. This is what I created, and if we open it, you can see that the material is shimmy. The shimmy is created by me. Okay, and if you open it, you can see that these are some parameters. These parameters are exactly what, if I click edit, exactly this parameter, right? So this is the function of the variable. They are the same. And if I switch here, I modify the parameters here, this will modify accordingly. So they are correspondence. Okay. So by this you could configure the parameter to this is used for the artist to make some make the visual effects more appealing. Okay, I think I have told enough, and this is the end of this video. Welcome for watching, and see you next time.